Hi and Assalamualaikum to my dear panels. Today, I would like to present my Bachelor Degree Project 1 with the title of Effect of Kenaf Fiber and Oil Palm Anti-Fruit Bunch Filler Surface Treatment and the Sizes to the Mechanical and Thermal Properties of the Recycled Polypropylene Composite. First of all, I am Abang Muhammad FAKHRULLAH bin Abang Ahmad and this study is supervised by TS Dr. Jeffrey bin Abdul Razak. First, for the presentation outline. I will be explaining the background of study, followed by problem statement, objective and scope, literature review, and finally, the methodology. For the background of the study, materials have evolved through time to become what they are now. Over the millennia, men have dealt with a wide range of material from the Stone Age, progressing to the Metal Age, and finally, the Polymer Age, by Smith in 2019. Wang in 2011 mentioned that polymer are undoubtedly one of the best material ever produced. Polymer alone somehow are not able to provide strength and load-bearing capability. As a result, the creation of polymer composite has continued to remain one of the most effective ways of influencing the polymeric material properties. MUHD et al. In 2000 also mentioned that natural fiber reinforced composite (NFRC) has lately been under the spotlight for their development and characteristics. A wide variety of fiber are available at low cost and good ecological traits. For the problem statement, in general, plastic pollution had grown into a threat to the global ecosystem and posed a direct hazard to nature and wildlife. This is by Webb et al. In 2013. Numerous researchers has mentioned that most of this plastic can undergo numerous biomagnification and may directly threaten the public health. In specific, plastic is hydrophobic material while nature fibers are hydrophilic by nature and require chemical treatment to improve the bond and compatibility between fibers and matrix by John et al. In 2010. There is not much specific research done regarding NFRC blends with the proper ratio to produce the most efficient polymer using recycled polypropylene reinforced with KF and OPEFB fibers. Common problems in NFRC includes worse filler dispersion, agglomeration, and premature failure due to the cracked initial point at the agglomeration site. For the objective, first, to evaluate the success of alkalinization of surface treatment performed to the kenaf fiber and oil palm anti-fruit bunch using FTIR analysis method. Secondly, to study the effect of surface treatment and sizes of KF and OPEFB natural fiber added as filler in recycled polypropylene-based composite at various loading by using several mechanical, physical, and thermal testing. Finally, to observe the fracture morphology of KF-RPP and OPEFB-RPP composite by using the scanning electron microscope SEM for the fabricated RPP field composite. For the scope, first, develop a polymer-based composite using RPP as metric with kenaf and OPEFB natural fiber as filler through melt bending method by using internal mixer compounding machine. Next, characterize the polymer-based composite various mechanical, physical, and thermal properties. The properties that will evaluate are tensile strength, impact strength, flexural strength, thermal stability, density, and moisture absorption. Thirdly, study the performance of KF-RPP and OPEFB-RPP reinforced polymer composite with regard to the surface treatment and sizes effect to the mechanical, physical, and thermal properties of the fabricated composite. And lastly, analyze the characteristic of failure mechanism and resultant morphology of the KF and OPEFB reinforced RPP polymer composite system by using the scanning electron microscopy SEM observation. Literature review. Grigor in 2017 mentioned that only thermoplastic polymer could be recycled since they can be remelted and reproduced into a final product. Goda et al. In 2018 mentioned natural fiber reinforced polymer composite NFRPC have the potential to be less costly, more durable, and more ecological friendly than the conventional polymer metric composite. Wisdom et al. In 2006 mentioned NFRPC are made up of a range of organic polymer with a short or continuous fiber at various reinforcement agents, allowing them to improve quality including fracture toughness, height, strength, and stiffness. Shavran and Alam Raju in 2019 mentioned that with the rise of environmental concern and awareness about the use of eco-friendly materials, the advantage of natural fiber composite over the epoxy resin polymer carbon fiber are low cost and biodegradable. Yusuf and L-Tayyib in 2008 mentioned OPEFB fiber also have excellent insulative and thermal properties. They are non-toxic, have wide range of application, and have high specific strength. Zampoloni et al. In 2007 mentioned kenaf fiber is material with exceptional flexural and tensile strength. As an alternative to glass fiber, this fiber is currently widely used as a reinforcement material in polymer composite. Next, for the literature review on surface modification. Alkali treatment are utilized to improve the adhesion between hydrophilic natural fiber and the hydrophobic epoxy matrix by C. Richa in 2008. By altering the surface fiber in the biocomposite, moisture absorption and the interfacial binding strength with the polymer matrix may be improved by Liu et al. In 2015. Study has been done by Ibrahim et al. In 2018 on the effect of alkali treatment on the kenaf fiber. The result from the study showed that kenaf fiber treated with 6% of sodium hydroxide has the highest tensile strength. For the methodology, as shown in the screen right now is the process chart from the start to the end. The process begins with the preparation of raw material, which in this study are divided into two parts, matrix and reinforcement filler. The surface modification will be conducted after the treatment of natural fiber, which will be my first objective for the study. The material then continues to melt bending process before going through compression molding. After the composite have been produced, the testing will be conducted on the specimen, which include the mechanical, physical and thermal testing. This will be my second objective for the study. After tensile testing had been done, the fracture surface morphology will be tested with SEM machine, and this will be achieved the third objective of the study. Then the result of the testing will be analyzed and studied to come up with the best conclusion from the study. As for the design of experiment, there are a total of 33 samples with different natural fiber, filler loading, treatment and sizes, where one sample with 0 width percent will be used as control. Preparation of raw material. For the preparation of natural fiber, the preparation are taken from previous study where the process are as follows. Kenaf and oil palm fruit are extracted to obtain the fiber, which known as KF and OPEFB. The fiber will be cut with dimension of 15 mm to 30 mm. Then wash and clean to eliminate any contaminant that may affect the result. Next, the fiber are left to be dried under the sun for 48 hours, then put in oven for 4 hours with temperature of 50 degrees Celsius until the moisture is gone. For the next step, the fiber are put into high-speed blender machine to grind into powder form. Afterward, shift using shift shaker machine for 20 minutes to separate it from the size of 32 and 90 micrometer. After that, the fiber powder are treated with chemical treatment, which in this study are using 6% sodium hydroxide solution for 24 hours. Later, the fiber will be rinsed with distilled water with 1% of acetic acid until the pH level turn into neutral. For the final step, the rinsed powder will be left under the sun to dry for 24 hours and continue with the oven dry with the temperature of 110 Celsius for 5 hours. The preparation of recycled polypropylene is based on previous study done by Grigor in 2017. The first step, propylene are collected from the recycle center in Melaka. Then the plastic must go through sorting process to separate the PP from other plastic. Then the plastic must go through sorting process to separate the polypropylene from other polymer plastic. Then polypropylene will be cleaned to eliminate any oil, dirt or contaminant that may affect the result. After that, dry the polypropylene in the dryer with a temperature of 80 degrees Celsius for 1 day to remove any moisture. And for the final step, the polypropylene will be put into a crusher machine to crush the polypropylene into a granulate or pellet size for the fabrication process later on. Now, proceed with the fabrication process. Based on the previous study done with the RPPKF and RPP-OPEFB composite of different composition will be prepared by internal mixture with temperature of 180 degrees Celsius, which is above melting point of polypropylene. The mixture will be run for 25 minutes with the speed of 35 rpm. The composite will be integrated with reinforcement filler with 0 width percentage as control sample and 10, 20, 30 and 40 width percent respectively. The size of the filler also varies, which have 32 and 90 micrometer. For the compression molding, the parameters are taken from the study done by RAZAK et al. In 2018. The mold are preheat with 35 degrees Celsius, then the molten composite are injected into the mold with the rate of 20 cm cubic per second and pressure of 1300 bar and the temperature of 190 degrees Celsius. The mold hold with a pressure of 1900 bar for 10 seconds. Finally, the composite are injected out from the mold and cooled down for 15 seconds. Then, the fabricated composite will go through testing. Finally, for the testing. The testing will be conducted according to ASTM standard. The standards are mentioned along with the testing. For mechanical testing, there are three types of testing include tensile, flexural, and impact testing. Then, physical testing will be test the density and water absorption for the composite. As for the thermal testing, we'll be using TGA analysis. Finally, for the surface and fracture morphologies, will be conducted using FTIR and SEM machine. That's all for me. Thank you.